All right, here we go. Quiz review 1-1 to 1-4. Let's bust these out, get you ready for the quiz tomorrow. So number 1, simplify the expression. So the idea with radicals are, I would like to try to get two radicals that are the same so that I can combine them. So for instance, this is just kind of a side note, but if I have like 3 radical 2 plus 5 radical 2, I am allowed to combine those and call that 8 radical 2's. You can almost think of this as like 3x plus 5x equals 8x. It's kind of a similar concept. So how I break them down though, because right now the 20 and the 45 aren't the same, is I'm going to look for some perfect squares. I'm going to look for some square root of 4s, some square root of 9s, 16s, all the perfect squares we talked about in our notes. So here's what I'm going to do for this one. I'm going to say 3 radical 20 is the same thing as 3 times the square root of 4 times the square root of 5 plus, well, 45, I could break that up as the square root of 9 times the square root of 5. So what I've done here is I've found 2 perfect squares that I can replace with just a whole number. So instead of 3 times square root of 4, that's really 3 times 2 square root of 5. Then over here, I have 3 times 3 times the square root of 5. And when I do my math, I get 6 radical 5 added to 9 radical 5. And 6 of them plus 9 of them gives me 15 radical 5. And you know you're done when the square root cannot be broken down with any more perfect squares in there. So I know that I'm completely done. Similar idea for number 2. So let's kind of scroll down. I'll go a little quicker through this one. So, and sometimes I don't really know what they're going to match up with. Like I just kind of keep going until I can't go anymore. Like 24, I could do 3 and 8, but they're not perfect squares. So I'm going to use 4 and 6. And then I have 3. 64 is 9 and 6. So that's helpful. And this is all being multiplied. So here I have 2 times radical 6, which is 4 radical 6's. Then over here, I'm going to have minus 3 times radical 6, which is 9 radical 6. And 4 of them, take away 9 of them, gives me a negative 5 radical 6. And you might be like, well, wait a minute, radical 6 can be broken down, but the only way to break it down is 2 times 3, and that doesn't really help me because neither of those are perfect squares. So even though the number can go smaller, it needs to have a perfect square as one of the factors. All right, number 3 is just a simplify, gather up like terms. So I need to distribute this negative sign through. So I'm going to have negative 6r plus 6. Then over here I need to kind of pretend this is a negative 1. I'm going to go negative 1 times negative 4r. That's going to be a positive 4r. Negative 1 times negative 10. Well, that's a positive 10. Now I gather up my like terms. I have negative 6r, positive 4r. That's 2 positive r's. And then my constants, that's a plus 16. Can't go any further. I've pretty much put everything together that I can put together there. And I think I screwed up. I just looked at my answer key. I think I screwed up right here because a negative 1 times a negative 1 is a positive 1. So check that. That's going to be 11. Glad I had an answer key that I made earlier to peek at. Right, I had to edit the video. Keep on going. Number 4. So use the equation to find the value of y when x is all of those values. So you could do this by hand, very carefully using parentheses. I'm going to show you how to do it using the graphing calculator because we've been working on that a little bit in class. So I'm going to pull up my handy dandy, calculator. And I'll kind of bring this down so hopefully you can see what's going on. Drag it right over here. And what I'm going to do is I'm going to turn it on. And I'm going to just clear this out just so I can show you how to input it. So I need y equals, which I already have, negative. Be sure to use the negative key down at the bottom, not the subtraction sign. 2, x is right next to the green alpha key. X, I use my power squared. My calculator, I got to go down to get back, like, I got to go over to get past the 2. There we go. Now we're on the right level. Plus 5x plus 5x plus 7. Hit enter to lock it in. Now, if I want the table, right up in the very top right above the word graph in blue, you'll see table. So I'm going to go second graph, which is my table. And now I can use the arrows to go down and see what I want. I needed to start at -2. So we have -11, 0, 7, 10, 9. -11, 0, 7, 10, 9. And those correspond with -2, -1, 0, 1, and 2. So if I needed to plot those dots, I could kind of have an idea what the graph looked like if I didn't want to graph it on the calculator. All right, moving right along, let's go up to number 5. Find the perimeter of the shape below. So this is just a application of combining like terms. So the perimeter means add up all these sides. So I have 3a's plus 6a's plus 5a's. I believe I have 14a's. Then I have -2, +3, so that's 1, plus another 1. It looks like +2. So there would be the perimeter for that shape. Moving on down, now we're getting into powers. So we're multiplying powers times powers, so we add exponents. So first we have coefficients. -2 times 5, well that's -10. Now we need to do the a's. A squared times a to the first. Well remember, a squared times a to the first, you just add the exponents. That would be a to the third. And then b to the third times b to the fourth is b to the 7th. And that's as good as we can go. Number 7, very similar. It's just the notation's a little different. So they put a dot in here as multiplying. You could just think of it exactly how the last problem was done. Now this one has some negative exponents, so it's going to get a little bit hairy. Let's see what we can do. 4 times 2 is 8. I have x to the first times x to the negative first. So x to the first times x to the negative first. Well, when I add the exponents, 1 plus a -1, I get x to the 0. And anything to the 0 power is just 1. So that didn't really do anything. I don't really need to write that, but I'm going to do it just to do it. Then I have y to the -3, y to the 2. When I add those up, I get y to the -1. Now, if you circled this, you get partial credit because you can't leave a negative exponent in your answer. So to fix that, instead of 8y to the -1, I'm going to throw the y to the -1 on the bottom and make it positive. So there would be your final answer. You could write this, but you probably won't see it on a standardized test or on an answer key. All right, number 8, we're now moving into division. Whenever we do division, we subtract powers. But the first problem is I see some negative powers. So when they're in a fraction, I simply throw them to the other side and make them positive. That's kind of how you fix it. So I'm going to just kind of keep this -3 over -2. Well, x to the -4th, to make it positive, I got to throw it to the bottom. So it's gone. X to the +2, that just stays down there. That's okay. The y to the first just stays down there. That's okay. And this y to the -2 has got to go to the bottom and become positive. So really, everybody ended up on the bottom. So a negative divided by a negative is a positive. 3/2 cannot be reduced. And now I just gather stuff up. I have 6 x's down there, and I have 3 y's down there. So I get 3 over 2 x to the 6th, y to the 3rd. Last problem on the first page, going down. Now we're using what's called the power property. We're raising powers to powers. So when you do that, you just raise everybody in the parentheses to that power. So I got to raise the -3 to the 2nd power. Then I got to raise that m to the 1st to the 2nd power. And then I have to raise the n to the 4th to the 2nd power. And when you're raising a power to a power, you multiply. So this number, -3 times itself, well, that's 9. m to the 1 times 2, and n to the 4 times 2. So that's using the power property. You could always just write this out long ways and just go negative 3m n to the 4th times itself. Now in this problem, it's not too bad because you're only doing it twice. If that exponent was an 8 or a 9, that would really suck having to write it out so many times. But you'll get the same answer. You'll get positive 9, m to the 1st times m to the 1st is m squared, n to the 4th times n to the 4th, add the exponents, and you'll get the exact same answer. Power property is just kind of a shortcut. All right, we have an interest question. This was in your notes. Use the equation up above. A is the amount that's going to be in your account. P is your principal or your starting amount. R is your percentage interest rate. And T is how long, what's the time that you're going to do that. So let's plug in some values. We start with $2,000. And 1 would just get me my $2,000 back, but I'm going to actually earn some money. So we're going to add 7%, which is 0.07. And my time, I'm going from 16 years old to 50, so I'm doing that for 34 years. So I just put the money in, leave it alone. Order of operations says you have to do parentheses first. So 2,000 times, that's 1.07 raised to the 34th power. And I'm not going to punch all this on the calculator on screen, but I end up getting a grand total of $19,956.23 when I rounded it. So not too bad for starting with $2,000. You almost tenfold it. Number 11, well, the big key in this whole equation is 0. Anything to the 0 power is just 1. So the answer to this problem is 1. You could kind of do it and break it up into individual pieces and go negative 3 to the 0 times a to the 4th to the 0 times b squared to the 0. But anything to the 0 is just going to be 1 times 1 times 1. So it's all just 1. All right, next problem. We have a power property, and we are raising to a negative power. So this is kind of a little bit of an issue. So what I'm going to do first, to fix that negative, I'm fixing this. When I want to raise something in the negative 3rd power, I put a 1 on top, and I make it positive. So that's step 1, is get that where it's supposed to go. And now I'm basically going to just raise everybody to the 3rd power on the bottom there. So I'm going to go, 3 to the 3rd power times b to the 1st to that 3rd power, and then a to the negative 4th times that 3rd power. So when I do all that, I end up with 1 over 27 b to the 3rd, a to the negative 12th. And then I'm like, well, wait a minute, you can't leave a negative exponent. So that a to the negative 12th is going to jump up on the top and become positive. And now everybody's on the right team. We have an answer that's acceptable, and we are good to go. All right, moving on down to number 13. Go to number 13. So we're dividing power, so we're going to be doing some canceling. Luckily, I don't see any negative exponents, so this is nice. So I have 2 x's on top, 3 on the bottom. So these two are going to cancel out and just leave one of those on the bottom. So I'm going to have 1x on the bottom. I have 4 on top, 1 on the bottom, so this one's going to cancel out and give me 3 of those. And the 4 just is still chilling down on the bottom. So I got y to the 3rd over 4x. All right, number 14, I see some negative exponents. So I'm going to fix those right away. So here we go. I got a negative, well, 2 divided by 2 just kind of cancels out. The a's are good. Right now I got 4 a's on top, 3 on bottom. The bottom ones are going to all cancel out and just leave me 1 a on top. The b's, when I flip them around, you got to go up top and become positive. You got to go on bottom and become positive. And so now I need to tighten up my b's. And I'm just going to end up with negative a, and there'll be one b on top. You know, the whole bottom disappears. I'm down to just one of those. So correct answer, just negative ab. All right, number 15. Multiplying scientific notation. So if you want full credit on the quiz, you got to kind of do this by hand using powers. So first thing is I'm going to just multiply the coefficients in the front. So 9.2 times 4 is going to be 36.8. And then for my powers of 10, 10 to the 5th times 10 to the negative 3rd, well, that's 10 to the 5 plus a negative 3. You add the exponents. So that's squared. Now that's kind of wannabe scientific notation. We're supposed to have a number between 1 and 10. So I need to decrease this by a power of 10. But if I decrease that by a power of 10, I need to increase this by a power of 10 so that it's still the same value. It still checks out. So there we go for number 15. Number 16, this is division, so kind of same idea, but I'm going to use division. So first of all, I'm just going to do 4.6 divided by 5.01. All right, so I'm going to divide these out, and I ended up getting 0.918. I rounded that off. You know, got to round it off kind of somewhere. I should probably say, you know, hey to the nearest whatever, but 0.918 times, well, when I do my exponents, I'm dividing 10 squared divided by 10 to the negative 3rd. So really I subtract the exponents. 2 minus that negative 3 is going to end up being positive 5. So I end up with 0.918 times 10 to the 5th. Again, it's wannabe. It's not a number between 1 and 10. So if I'm going to make this bigger to keep things balanced, I need to make this power of 10 1 unit smaller. So there we go. There's dividing two scientific notation numbers. All right, going back up the top. Now we're kind of headed towards easy street, determining whether things are functions. Remember, the big idea is one x cannot map to two different y's. Whether it's a picture, whether it's a graph, whether it's ordered pairs, whether it's a table, whatever. I see a problem right here. 9 was the input and 4 was an output. And then later on, 9 was an input and 8 was an output. So this is not a function. And you would justify it by saying, hey, 9 mapped to 4 and 9 mapped to 8. That cannot happen. Now, it's okay for two different x's to map to the same y. Like, that's totally fine. If I were to have a list of numbers and you had like a 5 mapped to a 7 and then a 1 mapped to a 7, like that's fine. There's no harm there. But you can't have one x mapped to two different y's. Number 18, when you want to do a graph, there's something called the vertical line test. So if you hold a ruler up or draw a vertical line, if it ever touches the graph twice, you have a problem. I don't think anywhere on here, no matter where I draw a vertical line, everywhere I draw it, it's only crossing the red at one place. So this is, yes, it's a function, passes the vertical line test. In contrast to that, number 19, I got like major violations all over the place. You know, if I pick this spot, say right here, you know, I have a problem there and I have a problem there. And if I drew it as an ordered pair, you know, I would have like, well, how about I pick a better one? How about I pick like, where's maybe right here? If I look at this point, well, that's at 3, 1. And then if I look at this point, well, that's at 3, 3. So I had this x go to two different y's. You know, so that was a problem. So it failed the vertical line test. Number 20 is just kind of a vocab thing. It's like, hey, what's the range of the function? So remember, the range are the y coordinates or the y values. So I'm looking for the set that contains those numbers. Usually they put them in order from small to big. So that would be B. I tried to trick you with A. A would be the domain. A would be the x values. All right, so just make sure domain is x, range is y, and you should be good to go. All right, hopefully this helped you out. See you tomorrow for the quiz. See you.